Now, coming to molarity, it is the number of moles of the solute present in 1 liter of a solution, right? Number of moles or even gram moles of the solute present in 1 liter of the solution, say at a given temperature. At a given temperature, because it changes with temperature. Now, this can be mathematically given as molarity M, capital M, is equal to number of moles of the solute N by volume of the solution in liters. Let me write it this way. V in liters. Now, we can just modify this because we know that number of moles is equal to. Now, the number of moles can be calculated as weight by gram molecular weight. Right? This is nothing but number of moles multiplied by 1 by volume of solution in liters, right? So this can again be modified as the same thing multiplied by 1000 by volume of solution in milliliters, right? So this is an important relation used for calculating molarity of the solution, right? Next. See, molarity can also be given as if number of millimoles of the solute is taken into consideration. Take number of millimoles of the solute by volume of the solution. Now in this case, take volume in milliliter. Okay. Next, let us go for different relations under different conditions. See, when strength of the solution is given. Okay. What do you mean by strength of the solution? Strength of the solution is nothing but the amount of solute in gram per liter of the solution, right? When this is given, molarity can be calculated. See, you got weight of the solute, which is already in the denominator of the molarity expression. Now, volume of the solution in liters is also there. So the thing that is left out is only the gram molecular weight of the solution, right? Let us consider that. Strength of the solution in gram per liter, of course, need not be given because strength itself generally refers to the thing that it is in gram per liter, then it's the gram molecular weight of solute. Okay. Next. See, when percentage strength of the solution in weight by volume is given, percentage strength of the solution weight by volume, we know that it is nothing but the weight of solute, okay, present in 100 ml of the solution. When this is given, molarity can be calculated using this simple formula. Percentage strength of the solution. You need to be little cautious. Weight by volume into 10 by gram molecular weight of the solution, right? This is when percentage strength of the solution is given. Next. See, when the same percentage strength of the solution is given in W by W, I mean weight by weight. You know, because weight by weight, I mean the weight of the solution is given, isn't it? Because it refers to amount of the solute present in 100 gram of the solution. Now that 100 gram of the solution has to be converted into volume for calculating molarity. So for that sake, we need other things like density or specific gravity. You need to be little careful. When percentage strength of the solution and density or specific gravity of the solution are given, we can calculate molarity using this relation. Percentage strength of the solution W by W into density or of course a specific gravity into 10 by gram molecular weight of the solution. Okay. Now there is an interesting point. when volume strength of hydrogen peroxide is given. Now, let me tell you what volume strength is. See, in general, concentration of hydrogen peroxide is expressed in volume, right? See, hydrogen peroxide decomposes to give this, or you can say this. Now, the volume of oxygen liberated, say in ml or in liter, at STP by the decomposition of one volume of hydrogen peroxide. That means, let me say this way. In general, we say that it is the volume of oxygen liberated at STP by the decomposition of one volume of hydrogen peroxide. Remember, this one volume is constant, but volume of oxygen changes. Let me give you an example. Say 10 volumes hydrogen peroxide. What do you mean by this? See, it says that this 10, of course, refers to the volume of oxygen. It says that 1 ml hydrogen peroxide, I've taken ml, you can actually consider liters also. 1 ml H2O2 decomposes to give 10 ml oxygen at STP. So whatever we have written here, that goes here. This is the only thing that changes. If I say 20 volumes, then that will be like 1 ml H2O2 decomposes to give 20 ml of oxygen at STP. And if you may remember this, perhydrol is 100 volumes, right? 100 volumes H2O2. What does it refer to? It refers to the thing that 1 ml of H2O2. This is not going to change. Remember, 1 ml of hydrogen peroxide decomposes to give 100 ml of oxygen at STP. Okay. Now, when volume strength is given, let me just give you the relation. You can actually see this in detail in some basic concepts of chemistry video if you want more clarity on this. Let me give you this. Volume strength of hydrogen peroxide is equal to molarity multiplied by 11.2. So this is what you can actually use. Okay. I can also give you one more. See, 10 volumes of H2O2 is equal to 0.893 molar. When this can be used for easy simplification. Of course, the same thing is what you get using the first relation. Hope this is clear. Next. Now coming to the units of molarity. You know, it is mole per liter. Moles of the solute present in liter of the solution. So, mole per liter. Let us see the effect of temperature. See, when temperature is increased, you know, volume of the solution also increases. Slight increase in volume can be observed. And we know that the volume of the solution and molarity of the solution are inversely related to each other. As a result, molarity of the solution decreases. Right. Now the other interesting. Let me tell you about different types of solutions on the basis of their molarity. Now, what is molar or 1M solution? Let us consider the basic relation. Of course, this is 1 liter, right? A constant value as per the definition. Now, if you want this to be 1, the number of moles has to be, of course, 1, right? So, molar or 1M can be defined as a solution having 1 mole of a solute in 1 liter of solution. If 1 mole of solute is in 1 liter of the solution, we call it molar or 1M solution. So that way, we can define many things. Now, if suppose I want the molarity to be 0.1, decimolar or 0.1M solution. Now, anyway, this is a constant, right? Now, if suppose this I want to be 0.1, then number of moles has to be 0.1, right? So 0.1 mole of solute is in 1 liter of solution. Then that is said to be decimolar. Okay. I can give you any number of things. Like for example, semimolar are 0.5M solution. It's that simple. 0.5 mole of solute is in 1 liter solution. Okay. You can take centimolar 0.01 capital M. See, 0.01 mole of solute is in 1 liter of the solution. Then you can take decamolar. Deca is 10M. It will be like 10 mole of a solute is in 1 liter of solution. Look at this. Pentamolar 5M. 5 mole of a solute is in 1 liter of solution. And one last, penti. Penti is 1 by 5. Deci is 1 by 10. Deca is 10. Just like that. Penta is 5. Penti is 1 by 5. 0.2. In this case, it will be 0.2 mole of the solute is in 1 liter of the solution. Okay.